Hi, my name is Muhammad Lukman bin Muhammad Rizan and my matrix number is 202367X784.
Alright, my name is Nur Nabila Bakisana and binti Muhammad Saiful Akmal. My number matric is 2023483222.
Hello, my name is Nur Ashikin binti Abdul Aziz and my matrix number is 2023450742.
My name is Aliana Sashal binti Rashidi. My matric ID is 2023822518.
Okay, let's go to introduction. Anthropogenic air pollutants have significant health impacts including toxicity, DNA damage, reduced lung function, pattern delivery, metagenic effects, and cardiopulmonary disease. The COVID-19 pandemic promoted global control measures such as Malaysia's Movement Control Order (MCO), which reduced activity to curb transmissions. Studies show the MCO's impact on reducing COVID-19 case and air pollutants like PM2.5 due to decreased human activity. Current research focuses on assessing air quality change during the MCO in 9 Malaysian cities, aiming to understand emissions effects and formulate policy to reduce urban air pollution, particularly in transportation sectors.
So right now I'm going to talk about the abstract of the impact of Movement Control Order (MCO) on air quality and health in Malaysia. For the introduction, MCO started date at March 18, 2020 to curb COVID-19. The objective of the MCO is to evaluate reduced human activity effect on air quality and health risks. For the air quality improvement, for the nitrogen reduction is average 40% decrease, and higher reduction is on Kota Kinabalu 62%, and the other cities such as Kuantan is 9%, and Alor is 38%, and Kota Baru is 15%, and lastly Ipoh is 27%. So next I'm going to talk about 2.0, which is material and method, and also 2.1, which is study era. It has 2, which is economic development in key cities and also impact of MCO on vehicle usage. For the economic development in key cities, which is key studies in Kuala Lumpur, Seremban, Johor Bahru, Kuantan, Kuching, Kota Kinabalu, and also Ipoh. For Kuala Lumpur, it's rapid growth from high pollution and traffic. For Kuching and Ipoh is growth in manufacturing factory, processing, shipping, and also tourism. For the impact of MCO on vehicle usage, it reduced vehicle usage during MCO to control COVID-19 spread. The impact of the MCO on vehicle usage is significant decrease in air pollution, showing the benefit of less traffic on air quality.
Data collection where March 18, 2020, all daily economics activities in Malaysia were prohibited in an effort to slow down the spread of the COVID-19, and also the concentration of PM10, PM2.5, SO2, NO2, O3, and CO in the air were compiled and compared. The Malaysian Department of Environment (DOE) provided the Howday air pollutant dataset recorded at the CAQMS, and the Malaysian Health of Ministry published the daily totals of COVID-19 cases for each state in the country. The portal, it updated cases for each country, stating its main objective are to assist individuals to achieving and maintaining a healthy standard for a productive economic and social life. How it can be achieved? Okay, this can be achieved by providing efficient and appropriate and effective prevention, treatment, and rehabilitation services with emphasis on the underprivileged.
Okay, for 2.3 part, MS trajectories. MS trajectories for Kuala Lumpur were analyzed using NOAA's HYSPIT software, simulating 5-day backwards trajectories before and during the Movement Control Order (MCO). The analysis used coordinates 3.13990 degrees north and 101.6869 degrees earth, and meteorological data from CDAS at 1.0 degrees times 1.0 degrees resolutions.
Okay, now I want to present to you all 2.4 statistical analysis. This study used descriptive analysis and statistical analysis to investigate the relationship between air pollutant concentrations between cities and the effect of MCO on air pollutants using SPSS v.21 and OpenAir Package R software. Okay, now I want to present to you all 2.5 health risk assessment. The study evaluated the non-carcinogenic risk of exposure to various air pollutants using the US EPA risk assessment guide for fine. The exposure concentration EC was calculated using EQ, and hazard equations HQ were calculated by dividing the EC with the reference exposure level REL. Results show no significant non-carcinogenic effects.
Next is 3.1, which is COVID-19 cases in Malaysia. Cases count as April 2020, Malaysia reported 5,425 COVID cases. In Selangor, which is the highest number of cases, 1,352, mainly in Kuala Lumpur. The impact of the pandemic has affected almost all the country worldwide. In Kuala Lumpur, it has higher number of cases with expected increase in that. One example of transmission factory, which is low temperature, mild diurnal temperature range, and low humidity may favor COVID-19 spreads. For the health effect, the air pollution witnessed aware defense, increasing COVID-19 prevalence and lethality. Further study needed to explore the link between air pollutant and COVID-19. Next, I will talk about 3.2, which is characteristic of air pollutant before and during MCO. Air quality measurement in Malaysia city studies overview. Cities monitor Kuala Lumpur, Alor, Ipoh, Seremban, Johor Bahru, Kuantan, Kota Baru, Kuching, and Kota Kinabalu. Pollutant measure daily 24 hours average concentration of 6 criteria air pollution. Its measure period before MCO, January 1, 2020 to March 17, 2020. And during MCO, it measure period by March 18, 2020 to April 21, 2020. For 3.2.1, I'm going to talk about PM10 and PM2.5. The impact of Malaysia Clean Air Policy MCO on air quality. The key finding, higher pollutant concentration, which is PM10 is higher in Kota Baru, while PM2.5 is higher in Kuala Lumpur. For PM10 reduction, it decreased in all cities except Alor, which had a reduction of 11.5%. For pollutant peak, in midnight peak observed in Alor, Ipoh, Kota Baru, and Kota Kinabalu. In Kota Baru, it increased in early morning, decreased until 6 p.m, while Kota Kinabalu 2 peak between 12 p.m. and 6 p.m. before MCO. The difference in different DID models, a negative DID value indicate reduced air pollution post-MCO, and PM10 reduced in Kota Kinabalu, Kuantan, and Kuching, while PM2.5 is reduced only in Kuching. For region contribution, slightly higher PM2.5 during MCO, likely from regional sources and suspended dust, while MS trajectory show contribution from the South China Sea and Northern Peninsula Malaysia. For comparative reduction, similar reduction in PM10 and PM2.5 observed in China, India, and Malaysia during COVID-19, while future reduction possible with improved gasoline quality and targeted pollutant policies.
Okay, the next part, 3.2.2, I will explain about SO2. Okay, SO2 concentration in Malaysia generally increased from early 2020 until the onset of the Movement Control Order MCO, except for decrease in Kota Kinabalu and a sudden drop in Kuantan. Johor Bahru experienced a continuous rise in SO2 level throughout this period, contrasting with fluctuating concentrations in Kuala Lumpur and Seremban before the MCO, which did not decrease during the MCO despite reduced industrial activities. However, average SO2 concentration were higher before the MCO compared to during it in several cities, with Johor Bahru showing an elevated level during the MCO, potentially influenced by nearby coal-fired power plants. The increase in SO2 concentration during the lockdown suggests contribution from coal-fired and shipping emissions. Effective air pollution regulation during international event highlight significant reduction in pollution level, emphasizing the impact of stringent measure in mitigating air pollution globally. Okay, the other part, which is 3.2.3, it is about NO2. During the Malaysian COVID-19 pandemic, most cities experienced decreased concentration of NO2 except for Alor, which saw peak level during the lockdown. Cities like Kota Baru, Kota Kinabalu, Kuantan, and Kuching show minor fluctuations without clear peak. Kuala Lumpur exhibit varied NO2 level before the lockdown, but ranged between 0.08 ppb and 2.2 ppb during it. The difference in different DID model indicate negative values for most cities, suggesting the lockdown had no significant impact on NO2 concentration except for Kota Baru, Johor Bahru, and Alor. Hourly and weekday trends generally show higher NO2 concentration before the lockdown, with peak in the morning and evening except in Alor and Kota Kinabalu. Overall, reduced motor vehicle usage and human activity during the lockdown significantly decreased NO2 level, with notable spikes on specific days like March 30 coinciding with a school holiday, and reductions attribute the decrease emission from combustion process, road traffic, power generation, and shipping.
The next slide is 3.2.4 O3. The study analyzed O3 concentrations in Malaysia city before and during the multi-city clean air, which is MCO implementation. No clear trends were observed, but Kuala Lumpur and Seremban showed similar trends. Only Ipoh, Kuantan, Kota Baru and Kuching experienced an average reduction of 0.8% after the MCO. All three concentrations were not affected by the MCO, possibly due to continuous productions via photochemical reactions. Okay, the next slide is 3.2.5 carbon dioxide. Before the MCO period, carbon dioxide concentrations in cities were higher than during the lockdown, with an average reduction of 1.2%. Kuala Lumpur experienced a large range between 0.55 and 1.57 ppm during the lockdown, but only a small reduction of 1.1% after the MCO. Restricted movement and reduced vehicles emissions, particularly in high traffic areas, contributed to the reduction. Strict pollution control measures also resulted in a 41.7% reduction in carbon dioxide concentrations.
Correlation metrics, where cities with strong correlation were shown, and during the MCO there were also somewhat a positive correlation. Somehow the correlation between PM2.5 and PM10 make it abundantly evident that PM2.5 and PM10 are significantly correlated, and between CO and NO2, indicating that these two pollutants originated from the same sources, such as incomplete fuel combustion or traffic emission, indicating that this pollutant originated from similar sources. Health risk assessment, the study indicates that before MCO, non-carcinogenic exposure to air pollutant had higher hazard quotient values except for PM2.5 and O3. The result for HQ and HI were below the acceptable limit of 1.0, indicating no significant non-carcinogenic risk from air pollutant exposure. The study suggests that in order to lower fine PM emission and health risk area, basic policies for vehicle emission and fuel standard improvement are headed, particularly in urban areas with high population density.
Here we are going to end this presentation. Last but not least, for the last point is 4.0, conclusion and policy implication. The study investigates the impact of Malaysian climate change on air pollution during the COVID-19 pandemic. Results show a significant decrease in NO2 levels, with Kuala Lumpur experiencing the highest reduction. PM2.5 concentrations increased post-MCO, except for O3. The study recommends systematic policies and small-scale mitigation measures for cleaner air. Okay, that's all from us. Thank you for watching.